for coming. My name is Sonny Scroggin. I'm one of the core contributors on the Phoenix Framework project. So I'm here to talk to you today. It's going to be kind of an introduction. So hopefully those of you who are not familiar with this project already will go away understanding more. I have a ton of slides, so save your questions till the end if there's time. If not, I will definitely be welcome to answer questions for you guys afterwards. So, all right. So, Phoenix. Phoenix is a framework for building modern web applications, API backends, and distributed systems. It's written in Elixir, so you do get beautiful syntax. Not that that matters. You get very productive tooling and a fast and efficient runtime, thanks to Robert Birding here at the Beam. So, Phoenix is a MVC-style pattern framework. So you do get models, views, and controllers for separation of concerns. Should be very familiar to those of you who have experience with other MVC frameworks like Rails or Python's Django framework. We have channels, which is an abstraction for doing real-time kind of data in your application. So talking to WebSockets, receiving events, doing pub sub within the server, and sending broadcasts out to other listeners. It's very easy to test, and it's also really fast. So anybody that's familiar with writing tests in Ruby on Rails, and you have to spin up the server, and it's really slow, and it takes 1,000 years to run your tests. In Phoenix and Elixir, in general, it's incredibly fast. So, and of course, with Phoenix, there's no compromise. I think someone was saying earlier that you have these great tools and you're so productive in your other frameworks and stuff, but then when it comes to running this stuff at scale, you start hitting walls. And with Phoenix, because of the Beam, you really don't have those problems. You don't have to choose high productivity or high performance, you get both. So, probably heard maybe some stories that Phoenix is pretty fast. So, how fast is it? This is some benchmarks that were produced. This is several months ago. As you can see, Phoenix up here is at 0.13.1 version. We just released 1.0.4 yesterday, so this is a little bit old, and we have done some improvements. So these actually should be faster now. So this was done against other frameworks in other languages. So Gin is a Go framework. Just right underneath plays from Scala. And of course, these are very fast, but Phoenix has been able to outperform her. And obviously, Phoenix was also benchmarked at a lower version, and you can see that the performance actually increased. Node, Express Cluster, Martini is another Go one that's actually not as good, obviously. Sinatra and Rails. So, and later on the slides, if you want to check this out, there's a gist there. So, Phoenix is an OTP application, and it basically just provides functionality for your OTP application. And so you can obviously start, stop independently with each other. It gives you all that flexibility. So Phoenix is not in itself doing all the work. It's built on top of the shoulders of some of these really, really awesome libraries. And so it's a multi-layer system, very modular and flexible. And Plug is a simple abstraction for dealing with web servers. It currently uses Cowboy, which is a Erlang HTTP server. And it's very small, lightweight, and fast. And we also have Ecto, which is a DSL for writing queries for interacting with databases. So, getting started. Hopefully the contrast is okay. Maybe that'll be better. So we have a mix task, a mix archive that you can install with this one line. Say mix archive.install, you give it this address, and it will download the latest version, or the tag version there. It will ask you if you want to create it and install it. Generating your app, we have this mix task called mix.phoenix.new. You give it the name of your application, and it will generate a scaffolding or a skeleton of your application structure. Then it will ask you if you want to fetch and install the dependencies. You say yes, then it will go ahead and run npm install, which downloads some Node.js libraries. And this is optional. What the hell? Brunch is a Node.js asset build tool. So when you're building web applications, you also have CSS and JavaScript and all that stuff. And probably the best tools for building JavaScript is probably a JavaScript library, right? So we pull in those. You can also, when you're generating the application, you can pass --no brunch, and it will not install those dependencies. So if you're just building an API backend that's going to be dealing with JSON and stuff like that, and you don't need the front end bits, then you can totally leave those off. So everything is fully customizable and configurable. Things can be added or removed. It will also run mix.deps.get, which will get the dependencies from Hex, which is the Elixir package manager. Once that is done, print out some instructions for further.
Why do you need Node.js?
Let's hold off the comments until afterwards. So then after, we're going to cd into the my app directory, run a mix task called ecto.create. That will create the database, which is here. And then we can start up the server. So there's an option of phoenix.server, or what I like to do is I like to run it in with the interactive Elixir console. So you can just say IEX-big S mix and give it phoenix.server, which will then start up your web server. It starts up the whole application and starts the endpoint with the web server turned on. So that will start up Cowboy on localhost 4000, and port's obviously configurable. And then voila, you get a nice landing page to start off with. So in the server logs, you can see the process of the request. So it was a GET request to /, which is the root. The debug message tells you what's actually going on in your application. You have a handler that's handling the specific request. And you can see down at the bottom there that the request was sent in 889 microseconds. So Phoenix is incredibly fast when it comes to rendering responses, and we'll see why that is later on. This is the file structure that you start with, and we have the most notable ones are the config directory, which holds all of your configuration for different environments. So you can have different configurations for development, production, if you have a QA server, or testing, and stuff like that, you can have files specific to each one of those. We have the lib directory, and what goes in here is generally your OTP-specific application things that are going to deal with supervision trees and processes that need long-lived running stuff. Then we have the web directory. And the web directory is for all of your application code that does not need to be, that doesn't hold any state. So all of your controllers for your web requests that are just handling each request as they come in. And this is separated out specifically because we have a code reloader for in development. When you change a file, you don't want to have to restart the web server before it picks up all the changes. And then, of course, we don't want the lib stuff to actually be reloaded as well. So they're separated for that concern. And, of course, a very important directory is the test directory. I hope you guys write tests. If you don't write tests, Elixir makes it very easy to write tests. The web directory contains, as I said, all of your web-specific stuff. So you have channels, controllers, models. You have the router, which routes requests and traffic. Static is for your static assets, JavaScript files and CSS. You have templates, which are your actual HTML files that get interpolated. And then you have views, which are modules that render the templates. The lib directory holds the endpoint, which we'll discuss in a bit. The repo, which is for the database, and the my app, which is where your actual OTP application lives, which starts the supervision tree. The test directory, we actually come with several test helpers that will help in making testing very easy. So if you run mixed test, then you can see we actually come with 4 passing tests already, which also gives you kind of an idea of how to start testing. We have several different mixed tasks that are available with Phoenix, and if you just list those out there, you can find out what they do. We'll go into some of them a little bit later. So, plug. If you remember back at that list of benchmarks, plug was at the top. So plug is actually the library that is really we're riding on the shoulders of. And it's a very simple abstraction that allows us to model a request-response cycle very, very simply. It's one single data structure. And we'll go into the details on that. But basically, it's a specification for constructing composable modules to build web applications. And so plugs are reusable modules or functions, and they're built to that specification. So plugs can be written to do pretty much everything. Authentication, rendering your templates, and so forth. And of course, I think in the previous slides, provides adapters for HTTP web servers, and the one that it's built with, that it comes with support for out of the box, is Cowboy. So the plug specification. There are 2 kinds of plugs. There are function plugs and module plugs. And a function plug is a function that receives a connection and a set of options, and it must return that connection. And this is its type signature. So plug.con.t, that's the plug struct, and it receives some options, and it returns the con. This is an example of a function plug. It is a function. It takes the con as the first argument, and some options. In this case, we don't care about them, so we ignore them. And then we take the con and we pipe it through some other functions that also follow the plug specification, which is you get the connection, you maybe do some transformation on it, and then you must return the connection. So module plugs are a slightly different twist on it. It's an extension of a function plug. And it expects that your module implements these 2 functions. So you init 1 and call 2. Init 1 takes any term, Erlang term or Elixir term, and it initializes these options. Of course, it could be just an empty list. It doesn't matter. And call 2 will take the connection and the options that are actually initialized in the init call. And generally, init is actually handled at compile time. And so you can do your initialization of the options at compile time, and then those compiled options are what is being sent into your plug's call to function. This is an example of the JSON header plug, but pulled out into a module plug. Does the exact same thing. And this is the data structure for the plug.com. So it is a struct in Elixir, and it has these different keys and different values that you can use. They're all for different things. So we have a request fields, which like you have host, the method of the request, the HTTP verb for like to get or post or put. You have path information, all this kind of stuff that you have access to when trying to receive a request and build a response. You have fetchable fields. Fetchable fields are stuff like cookies and request body and things like that, where you need to actually read them from the web server, what the web server has given you. And these are fetchable fields because by default they're not fetched for you until you actually exclusively fetch them. And that is for performance reasons. If you don't give a rip about the body because of a particular request. You don't need to try and read the body if you don't want to, because that's more expensive. So response fields, so you have the response body, character set, response cookies and headers, and the status. And so all those will be set when you're sending a response. We have connection fields. So assigns is an area in the connection where you can actually place. It's a map, and so you have keys and values, and those keys and their values basically become variable assignments throughout the templates and things like that. And you can use these for your own kind of variables or values that you need to keep track of through the connection cycle. Of course, there's also private fields. The private field is used for frameworks like Phoenix and various other libraries. So there are 3 main plugs in Phoenix. So we have the endpoint, the router, and we also have controllers, which are plugs. The endpoint is basically the start of the boundary of the requests that come into your web application. And it's the interface for the application provides to the underlying web server. So overall, an endpoint has 3 responsibilities. Provides a wrapper for starting and stopping the endpoint. It's a provision tree. It defines the initial plug pipeline, which we'll get into in a bit, and it hosts web-specific configuration. This is an endpoint. We have, essentially, it's what's called a plug pipeline. We'll get to what that is a bit, but this is a plug, and it also specifies other plugs. And each of these are, so in this case, we have plug static, which is a module plug. Plug.static is the module name. And then this keyword list here is the options that you are initializing that plug with. So at compile time, these options will be compiled in with init1, and then at runtime, it will be passed in to this module's call to. We also have this code reloading section here. So this is only turned on if you have set the flag for reloading code, which is generally only in development, so it shouldn't be on production. And this sets up a WebSocket that will tell your front end, hey, code changed, go ahead and refresh yourself. So we have live reload and all that stuff built in. So it's really nice for front end developers when you're testing a feature and you want to change some code and automatically have the browser refresh itself. So some other plugs that are in there is plug parsers, which parse the body based on the request. So if it's a URL form, like it's a form submission, it'll go through URL encoded or multi-part if there's file uploads. And then we have JSON parser automatically. Some other plugs here for some various things. And then we have sessions for reading cookies and storing cookies and all that kind of stuff. We have cookies are signed by default and also verified. So you can know that there's no tampering happening with cookie values. There's also a flag or an option here that you can add, which is called encryption salt, which will, if you have that in there, then your cookies are actually encrypted as well. So it's not turned on by default because it's obviously more expensive, and if you don't need it, then don't bother. And then lastly, we plug the router. And so the router is basically responsible for routing traffic to other parts of the application. So we have a set of macros that allow you to generate routes that dispatch out to other controllers and actions. And these macros are generally named after HTTP verbs. So we have get, post, put, patch, delete, etc. We also have some other ones that you'll see. And so this is an example of a router. We have this scope macro that allows you to set the scope of a route. So in this case, this is the root, so the slash. And my app here is just an alias so that you don't have to always prefix your actual controller with myapp.pagecontroller. So get/pagecontroller is the module that will be routed to, and then index here is the function inside of that module. So we also have this macro called resources, and resources will generate a full RESTful style routes for that particular endpoint. So you'll have an index, a show, a update, destroy, etc. There's also obviously the non really RESTful ones, which is like edit and new, but those are obviously necessary. And then we can also, if we pass a block here, then we can also nest resources within other resources. So the router actually leverages pattern matching. So these here end up getting compiled into this here. These are just the function heads. So at compile time, you end up getting all of these function definitions generated for you, and then at runtime, the beam takes over and does what it does best, and actually just pattern matches on the request, and does the right thing. So it's incredibly efficient. Most other frameworks obviously like try to use like regular expression matching and all that kind of stuff, and it's a lot slower. So they spend about 30% of their time trying to figure out where we need to route the request. And obviously in Phoenix it's incredibly fast. So something like this, this get slash ends up, here's the full function definition. We take the con, pipe it through a couple of plug functions. We put Phoenix pipelines and the Phoenix route, which is a function, an anonymous function that will end up routing the controller. And then we pipe this to a function called browser, and I'll explain that later on how that works. The router also has mixed tasks, so you can say Phoenix.routes, and it will generate a big list of all of the routes that are defined in your application. The ones on the left here are the helpers. This is the HTTP verb. Here's the pattern of the route, of what it would look like, and then the module that will handle it, and the function that will go to. So pipelines. Pipelines group functions together and to handle common tasks. So this is kind of familiar to most of us in programming. We have functions that take, we have this thing that we pass in, but it has to, like, you have to read it inside out backwards. So it's not very friendly. In Erlang, you kind of do this type of thing where you have these temporary variables that you have to pass around, which kind of sucks because if you end up removing or adding anything here, then you've got to find all the places where you changed all that. But really what we want is something kind of like this, where you can just pipe the output from one function into the input of the next. And so with Phoenix, we have the pipe operator. So you end up with something like this. So you get the connection, we pipe it through to the endpoint, pipe that through the router, pipe it to the controller, and then we end up sending the response. So, I mean, really that's all we're doing in web development. We get a big giant string from the request, we parse it out, we do some stuff with it, and then we end up at the end turning it back into a string to send to the client. And so this is just that function pipeline. So routers also have pipelines. And so we can define a pipeline here like this, and a pipeline is just a plug, but it allows to define other plugs within it. And so we can say plug accepts, and this will ensure that it sets up the ability to handle HTML requests, or you can have JSON and so forth. Plug fetch session will fetch the session from the connection, as that is a fetchable field. You can't have access to it until you actually fetch it. So we fetch the session, we fetch flash, which is messages that you can put in the session. So if you want to display a one-time kind of message to a user. We also have some other things which are useful for protecting form submissions and putting other secure browser headers. So to use that pipeline, in your scope, you can just say pipe through and give it the name of a pipeline that you want to pipe through. And this can be a list of pipelines, so you can have the browser pipeline, and then you can also have, like, if it's an admin scope, you can also have like an admin's pipeline that will automatically check to make sure that the current user of the that's signed in is actually an admin. and do some things like that. So generators. This is a very useful tool, especially when you're learning. You can generate different scaffolding for your applications to get up and running really quickly. And we have several different generators here. We have ones for channels. We have Gen.html, which will generate files for an HTML-based resource. So it'll provide you with templates and the ability to create forms and all that kind of stuff. Then we also have JSON for just if you're doing an API. It will avoid some of the other files. We have generation for models, which will be our modules that interact with the database, and they hold the database schema and all that good stuff. So if we wanted to generate a post resource, we're creating blog, which is stupid, but you know, it's a good example. So mix Phoenix Gen HTML, you give it the name of the model, which in this case would be post. You give it the pluralized version, which would be the name of the table, and also generally your route endpoint. And you give it some attributes. So we have a title. The default value of any attribute is a string, so we don't have to specify here, but the body is a text type. So we say :text. That will end up generating all these files for us. And then we have some steps for the user to add the resource to the router. So we do that, we plug that in there in the router. Then we run the migration. So we say mix ecto.migrate, which will go ahead and create the table in the database and add all the columns and all that good stuff. And then if you visit /posts on your application, you'll see this page automatically for you. You click the new post button, you get a form. You try to submit the form without putting anything in, and you get validation errors. And if you fill stuff out correctly and submit it, you automatically get, it's basically create, read, update, destroy, all automatic for you. And we get some buttons here for showing a resource, editing, and all that good stuff. So controllers, which is our third and final plug. Basically here, controllers also have pipelines as well. We can plug other plugs in, and those will happen before hitting these actual index or these actions, as we call them. And one note here is that this we actually have a macro that allows you to add a guard to these plugs. So you can plug it only when the action, which is the function that's going to be dispatched to, is in this list here. So create and update. So this scrub params ensures that if a form is submitted, that if it's submitted with blank values, that those blank values get turned into nil values. And so that way you can do, it works well with the data validations in the model. So, explaining all the actions here, we have the index, which you would do get to /posts, which will list out all of the posts. So we're just getting all the posts from the database, and then we're rendering. This is for showing a single action. We can do pattern matching on the route params. So we get an ID from the URL, which will then pattern match here in the route params, and allows for a very nice deconstruction of your route params. We won't get into ecto stuff, which is the database, which is all this change set stuff. There's just too much information to cover in this short period of time. So, but this is basically how you do it. It's really simple. And all of this code is what's generated for you. So if you run these commands, and follow the slides on afterwards, you can see all this generated code. And similarly, this is the edit, update, and the delete action. So, views and templates. We have some frameworks kind of like combine them, where like in Ruby on Rails, for instance, a view is your template. and they have separate modules and stuff for like helpers and stuff like that. And we've actually separated them out. A view is responsible for rendering a template, and a view also provides helper functions for using your templates. It also is what makes Phoenix so fast at rendering speeds, because the templates are actually compiled into function calls. So if you create a template at a specific path, at compile time, that string gets created into a function call that will work for that as very fast. So this is a view. If we have a post view, we could say we want some helper functions for like showing the title. We want to upcase the title. It's a bad example, but we can pass in the struct of the model, the post model that you get here, and then you just match on that title and upcase it. We also have render, like if you're rendering JSON, for instance, you can have render index.json. You'll get a map of your assigns that are currently available, and posts should be in there. And we can create and return a map, and that map will then be encoded into JSON. So we can also have these nice functions called render many, which will take your posts and it will call show.json on this view module, which will then be this render function here. So render, which will then actually take, and you can specify the keys and the values and all that good stuff. So the cool thing about this is it's very explicit, and there's no wondering about what am I rendering, what data am I rendering, which is probably pretty natural to most of you in here if you're functional programmers. This is a template. So it's called EEX, which is embedded Elixir, and it gives you have regular HTML in here, but you also have these tags which will evaluate Elixir within them. So this is an example here of using the title helper function that we provided in the view file, and we're just passing in the post, which will then use the post.title to render it out with upcase string. So the last thing we'll talk about is channels. Channels allow you to route hub sub events to channel handlers in your application. So by default, Phoenix provides support for both WebSocket and long polling, and it's actually pretty extensible. You can create create your own transports for other things. So if you want to create a transport for XMPP or CoAP or any of these other protocols, it's very easy to do that. There's several other things available on HexPM for like RabbitMQ, for instance, and so you can handle all that. We have the channels are similar to controllers, but they're bidirectional. So obviously you can send data to the client anytime you need to, and you can receive data from the client anytime. And we ship with Phoenix.js, which is a JavaScript client. So to use channels, you can use the socket macro in your endpoint, and you get the path and the module that will handle the socket. And the socket, you can specify your channels. So it's kind of like namespaces and routing for channel data. So we can say rooms, : star, which is a wildcard, so anything that's sent to a channel that has this prefix will automatically go and be handled by the room channel. You can plug your transports, so this one supports both WebSocket and long polling. And we provide a connect function, and there's also an ID that you can reference later. So in this case, when you're connecting, you can do some validations to make sure that the user is authenticated and all that good stuff. And if so, then you return the socket and you're good to go. Channel, you can also ensure that people can actually are authorized on a particular channel. So you can do the different data and handle that all here. So there's a join function, which takes the channel name, and this would be like rooms, lobby, or you can have multiple join clauses as well for different rooms, for instance. It will receive the message and the socket, and you just need to return OK socket. You've got also handle info, which will handle messages that are sent to it directly. So this is just all OTP stuff. So in here, in the join, we're sending ourselves an after join with the message so that we can actually handle it during the setup. And this just broadcasts on the socket. User entered, so if somebody's joining, you can broadcast out to everyone and say, hey, this person joined. And other things like ping, you can handle. And then we also have handle in. So handle in, there's also a handle out, which will allow you to filter messages and stuff like that. Handle in takes an event, so a new message, gets the message and the socket, and then of course you can handle that by either broadcasting or a reply or something like that. So Phoenix.js, this is essentially kind of how you would use it. This is all ES6 or ES 2015, whatever name they finally finalize on. The import socket from Phoenix, and then you would say let socket new socket, give it the route path, which is what we set up in the endpoint, and then you can set up logging and stuff like that on there as well. Then you can connect with the socket, give it some parameters for your connection. You can also do tokens and things like that. We have Phoenix.token, which allow you to ensure that the person that's trying to authenticate is supposed to be able to. With the socket, we can create a channel, and with that channel, we can join. And Chris McCord has done some nice creative things to give this JavaScript some like kind of pattern matching results here. So we're saying receive, and if you receive these message patterns, ignore, and you can console log some stuff. If you receive an OK, then good to go. And then there's the after, which will handle timeouts. You can also set up error handlers on the channel when stuff bad happens. And then pushing a message, you can use channel.push, give it the event name and the payload. So we have like something like user and then the body, and then handling channel incoming messages on the channel is very similar here. So when we receive a new message, then we will receive that and then do something with the DOM or whatever. So that is pretty much it. We have some really great guides. If you go to phoenixframework.org, I imagine that the guides are so good that people didn't want to sign up for a 3-day Phoenix workshop. So yeah. So danke. That's it.
One question. Who brought you in?
Is it possible to override generators? For example, generator HTML generate templates using rid of stuff. I want to get rid of.
Yes, you can. You can actually add your own templates within your project, and you will actually use your own custom templates for that. So, and I think there's probably some guides on doing that somewhere. If not, then we'll probably do that.
Okay, thank you.